glass house used for cultivation in cold countries. Okay, the glass house means it will allow the incoming solar radiation and prevent the outgoing reflected solar radiation from the inside of the glass house. So, in effect, it will increase the temperature of the glass house. Like that, gases, CO2, methane, etc., behave in the same way by allowing high frequency radiation but not allowing low frequency or high wavelength radiation out of the atmosphere. If these gases were not there, they will freely go to the outer atmosphere and there is no effect of warming. Due to these gases, it will be absorbed and reflected back from the atmosphere. So the average temperature of the atmosphere is increasing over the century. It is not a sudden increase. You can see what is the CO2 concentration over the years.
Sir?
Yeah.
Sir, my name is Ayan Bhuwal. So last class also I asked you to join me in the Teams, MS Teams, so that I can attend the class.
We
Sir,
are
you
not
still...
in the team.
Yes, sir?
Right now, you are not in the team.
No, sir, you haven't added me yet.
Okay. What is your register number?
20 BCE 2875.
Pardon?
20 BCE 2875.
877. Okay, I will add you. Okay. Right now, are you able to attend the class?
Sir, I'm able to attend the class through the link my friend just sent me.
Okay, I will add you after the class. Okay, no, will
Okay,
be
sir,
there.
please.
So this is the concentration of CO2. Okay, over the years. So you can see this is from the year 18,000 to now. Okay, it is increased. It is expressed in ppm, part per million, in the concentration. Okay, not only CO2, atmosphere will have many other gases. So per million, what is the part of the CO2? Okay, so it is seen prehistoric era 1000 AD 1000, it is 250 and it remained 250 plus. Okay, 250 that means 275 like that. It remained for long until the year 1800. From the year 1800 onwards, it started booming up ppm, and now it is 400 ppm like that range. Okay, so a magnificent view is in the right side. So 275 or nearly 280. Now it is 340. Right. 2000 year 2000 means 340. Okay. So why it is happening? What happened in the year 1800? Anybody?
Vehicles.
Not only vehicles. Vehicles means IC engines 90-30 like that. Industrial revolution happened in the history of humankind, right? You might have studied in your school history book. Industrial revolution. What is industrial revolution? Until 1800, people were using this manpower, horsepower like that. There is no industries. No, there is no fossil fuel usage. So in England, this Renaissance, all these things happened. No, what is happened? People found the what is the power of what is the engine? Steam engine. Okay, earlier steam engine was there and not IC engines. So Nicholas Otto, 1790, like that, invented steam engines. Okay, so for running steam engine, coal was used. So industrial revolution started. Apart from human and animal power, people used the power of industrial industry. Okay, that means industry run on coal, later oil, gas, etc. So 1800 onwards, people started using fossil fuels that triggered the CO2 accumulation. So within 200 years, now it is 2021, no? So 2000 means 200 years, 21 means 21. So 221 years, all these problems arise. Now what is the effect? Population is also increasing and it is having high demand on fossil fuels. Okay, some 30-40 years there was only few vehicles. Now everybody has vehicle. So as population increases, greenhouse effect increases. Total greenhouse gas emission 2000 year. What is the total world greenhouse gas emission? 34 gigaton CO2 equivalent per year. What is CO2 equivalent? It is not only the CO2, many other greenhouse gases are there. So cumulatively they have expressed equivalent CO2. So 34 gigaton. It is a huge quantity. No? That much accumulated per year in the year 2000. So now it is more than that. You can refer latest data. So this is the country-wise population, North America, Europe, Middle East, yeah, greenhouse greenhouse gas pollution. Okay, tons of CO2 per year per person. So developed countries means more contribution. Developing countries means less. So say Asia, India, etc. comes in Asia. We are contributing less per person, but cumulatively we are doing big because our population is more. Right. So what is this future effects? Even the minimum predicted shift in the climate for the 21st century are likely to be significant and disruptive. Prediction of the future climate change are wide-ranging. The global temperature may climb from 1.4 degree to 5.8 degrees. The sea level may rise from 9 to 88 centimeter. Thus, increase the sea level. This country is expected to range from significant catastrophic. This uncertainty reflects in complexity. So there is with now the temperature, average temperature of Earth atmosphere 1.4 to 5.8 is expected. Now you can check what is average temperature. So in 50 years, 0.5 degree increase even causes huge catastrophic effect. What are all the effects? Severe storms and flooding, food shortage, short of freshwater supply, short of biodiversity, increased disease. So are we witnessing these things now? What do you say? Severe storms and flooding. Are you aware of it happening in the world? Yes or no?
Yes, sir.
So you can read out Europe, Germany was under flood, China was recently under flood. So 2 years back, Kerala, my own state, consecutive years, very severe floods was there. It is happening. It is witnessing. Okay, it is not a prediction. Indonesia is sinking. Why? The sea level is rising. Many buildings are under sea water. So not only Indonesia, in my state, Kuttanad, the backwaters are there. You might have seen, right? Tourist place. Where the sea level, land area is below the sea water level. Okay. So the main transportation, not main, major transportation mode is the small boats. So that has been continuing. But now what is happening? Sea water is introducing into land area due to average sea level increase. Okay, huge problems are there. So it is happening. So coming to solar, we are talking about solar because it won't contribute to CO2. Okay, whatever solar we are using, there is no fossil. Current solar, okay. Previously, solar is trapped by animals and they formed fossils. But live solar, if you are using, there is no addition to greenhouse gas effect. So is the solar enough? The question is there. Solar is enough quantity wise, but quality wise it is not enough. Why? You can see solar radiation, this green box, right? Green box is total solar radiation. Current global primary energy consumption. Primary energy means the energy that is available as such. Coal, oil, crude oil, uranium, this fossil fuels and other nuclear fuels. So solar, all other primary energy cumulatively current world is using this small red one, okay, in a corner. So compared to that, what is available to continents is very large. But why don't we cannot use solar radiation completely for our purpose? But what it is prohibiting? Anybody? We have the solar radiation available to Earth in a large quantity, but we cannot harness it for our purpose. What is the prevention? Why we are not able to use?
So less space to panels.
That means solar energy is a diffuse energy. Right, diffuse means it is everywhere there, but we cannot harness it. If you have studied thermodynamics, you might have seen efficiency is directly proportional to temperature of heat addition. Right. So in an IC engine, 30% efficiency is there means you are adding heat at very high temperature, 300 to 400 degrees in the IC engine inside, and rejecting to ambient temperature, 30 degrees. So 1 minus 30, that lower temperature by higher temperature. So 1 minus a fraction. So 0.3, 30 is there. But if you use solar energy in a device, this heat addition temperature is not there. 300 degrees Celsius will not be there. You can expect maximum 60 degrees, 70 degrees without concentration. With the concentration, you can have some 100 plus degrees. Okay, 400, 500 also possible, but with huge instruments, collectors and concentrators, that is not possible for a vehicle, combat vehicle, etc. So solar thermal we cannot use in vehicles. What about PV? PV also very diffuse. Actual efficiency is 10%, 13%, right? So if you want 3 kilowatt means how much area you can need? Maybe 20 meter square area or 50 meter square area. So in a car, there is not enough space for that much panel. And also it is intermittent in nature. If you are getting some power this time, next time it is not getting. So storage is required. So due to all this diffuse nature, big size, concentration requirement, not reliable in time, that are prohibit it, utilization in a big way, right? So this is, I am giving this slide to show you that quantity wise it is enough, but quality wise it is not. Quality means second law, thermodynamics. Okay. If you take 1 liter of diesel, how much we can expect? Calorific value is 42,000, right? Kilojoule per kg. 42,000 kilojoule per kg. So 1 liter, almost 1 kg, you can expect 42,000 kilojoule. So that is why we can store in a fuel tank and we can have a good range of automobile with petroleum or diesel. But if you want that much range, panel directly means huge area required. If battery also, you can expect 300 kilometer like that, current technology. Okay, Tata Nexon. So if you use Tata Nexon for your fleet, it won't contribute to global warming if you are using a renewable energy to charge it, right? If you are using grid electricity, this is not a clean mode, right? If electric, nowadays everybody is talking about electric vehicles, right? Am I audible to you?
Yes, sir.
Yes, sir.
So nowadays the trend is
Yes, sir.
electric vehicles. So do you think it will mitigate the global warming effect? It will mitigate global
No,
warming if we are using all the vehicles are charged from solar PV or wind, like that, renewable energy sources. If you take this grid electricity mainly come from coal power plants, thermal power plants, like that. If you are using that, you will not pollute in a city, but you will pollute in other place. So that is the scenario. So our clean electric policy will be to the end, it will be beneficial if you use more renewable energy. So more renewable energy means more PV power plants, etc. Even though it requires land, now governments are promoting on rooftop solar panels. That means if you install in your rooftop solar PV, you can use it. And extra means you can sell to the grid and government will give the price. Net metering is coming. So all these things are there, but still the solar all these things have demerits. That means intermittent nature, storage, all these things. So let us go to our subject. What we will study in the future in this semester. What we will see now. So now I will share a new slide. Is the new slide available?
Yes, sir.
So I will give the what is there in our syllabus overall. Okay, already we have discussed it somewhat. So module 1 means solar radiation. So first of all, we are studying PV means you should have an understanding what is solar radiation, what is its components. We know that it is electromagnetic waves. So we will study some more deep what is electromagnetic waves, what is the components, what is the sun-earth angles, how solar radiation is not constant, right? Our tropical regions, we are abundant in solar radiation. If you go to Western countries, it is not that much. Okay. If you go to Antarctica, what is happening? 6 months sun full, 6 months dark, like that. So depends upon solar position, sun's position related to sun, it varies, fluctuates. So sun at angles relationship. Estimation of solar radiation, Page-Armstrong method. So estimation means you can either estimate solar radiation or measure solar radiation. Okay. How much solar radiation we can expect in a given location? We can use some correlations and get an estimation. That is one method is Page-Armstrong method. Another one is measurement. Measurements means we will measure using some devices. If you want to measure a current, we will use ammeter. Voltage means voltmeter. Like that, solar radiation we can measure using pyranometer, pyrheliometer, shader ring pyranometer. Some devices are there. We will see what it is. That's about the first unit. Once solar radiation is understood, we will go for PV. What is PV physics? Okay, we understand now that it is PN junction is there. We need to dope a material and get to the junction. Once solar radiation is impinging on that junction, due to photovoltaic effect, we will get a potential difference. If we connect a wire over this potential difference, we can get a current. Current means nothing but electricity, right? So that we will see in the unit 2, basics and the basic terminology. Performance parameters, STC, standard testing condition, NOCT, normal operating cell temperature. All these things we will see in the unit 2. And how to estimate module output, module selection, cell module manufacture, all these things. Unit 3. What is unit 3? Electrical concept of solar cell. So solar cell is producing electricity. So for any electrical devices, we can have a circuit. So equivalent circuit of a solar cell we can study. Cell equivalent circuit estimating VOC, ISC. What is VOC? Voltage, open circuit. ISC means current, short circuit. We will see these terminologies. Then effects of shading. Solar panels, if they get shaded, what is the effect on power output? All these things we will discuss in module 3. Module 4 means components, system components. So these panels seldom work on isolation, right? They will be in conjunction with other components. So battery will be there for storing usually. Inverter will be there if our appliances are AC. this solar panel will always produce DC current. So if you want to run on AC, we should have an inverter, DC AC inverter or converter. So that battery inverter, its types, operating parameters, performance, and then charge control. Charge control means a electronic device, right? This battery will not get overcharged. There should be some control. Okay, battery should not drained out completely. There should be some control. So this charge controller controls all these things in this system. Then MPPT means maximum power point tracking. That means you will study what is the voltage current relation in a cell and a PV module. So you should get, we understand that power is equal to voltage into current, right? Electric power is equal to voltage into current, simply. So there is a curve variation of voltage product. Voltage into current will have a maximum value. That we have to track. So maximum power point tracking is a circuitry introduced in the charge controller itself nowadays. Charge controller comes with MPPT. Okay, you can check your any commercial PV manufacturer brochure. MPPT charge controller will be there. That means it will ensure that maximum power is obtained under a given climatic condition. So we will study about it, what it is. Then system configuration. We have so many configuration. Standalone system. That means PV panel will be there, use will be there, and this battery and inverter will be there. Grid connected system. That means PV panel will be connected to grid also. So any excess power means taken from grid. There will not be any storage because whatever electricity produced, it is supplied to grid. Okay, storage is not there. So configuration we will understand it is fourth module. Module 5 means system sizing. What is sizing? We should get the correct number of panels, correct battery AH rating, correct inverter rating for a given application, right? If you purchase a new car, what is the car? Electric car. That time it's on you purchased. You are very environmental sensitive person. You don't want grid. So you want to purchase PV for charging the Tata Nexon. So your question is how much kilowatt of solar PV panel? Okay. If we cannot get a kilowatt panel as such, so 300 watt panel, how much number to get the rated kilowatt? What is the cost of it? If the solar radiation fluctuates, you want to store in a battery. What is the ampere hour rating of a battery? How much it will cost? All these the questions. So it is studied under system sizing. Sizing standalone PV system, load estimation. So on this, how much electricity is needed to charge this tap and on? That is the load. Okay, estimating the load. If you want to power your light and fan in the house, that is the load. How much the load means you have to calculate it, corresponding to the power rating of the equipment. Fan, light, etc. Power rating will be there. 40 watt, 50 watt. Number of lights into number of operating hours in a day. So load we can calculate. Accordingly, we can size, estimate number of panels. Array sizing, battery sizing, matching module and battery and iteratively. Wire sizing, sizing charge controller, inverter, MPPT. It is nowadays commercialized. Okay, standards will be there because solar PV industry is big and booming. So many standards will be there. We will familiarize with it. What is happening in the industry? Module 6 is system installation. Once we have fixed the rating, we have to install it, right? So there is procedure, site identification module, orientation, ground and roof installation modules, standard practices in system installation. We should take some precautions, right? If we put a solar PV in a grid, if there is a maintenance in the grid, it should be switched off, right? So if the grid is not connected with the PV, we can switch off the fuse in the grid line. But if it is grid connected, how to switch off the PV electricity? That is a question, right? Otherwise, the technicians will be shocked. So there is some procedures and precautions in the grid connected PV, standalone PV, etc. You have to understand it. Codes are there. Electric codes and practices, islanding, grounding, and other safety practices. So these are all about PV system working, its selection, its installation, etc. Up to module 6. Module 7 is completely about economics. What is economics? Money matter, right? That means nowadays everybody opting PV because it is attractive in terms of money. Solar panel prices came down. Electricity unit price produced from solar PV is on par with or even less than the grid electricity, 2 rupees or 2.5 rupees per unit. Grid electricity may be 3 or even high, okay, 5, depending upon the production. So how to PV economics? There are some terminology, project payback. If you invest some lakhs of rupees in a PV, how much time it will take to get back your money? That is payback period. How to calculate it? Then, if you invest in a big solar power plant, how much will be the unit cost of electricity? Will the people buy it? Okay, people buy your electricity in a big project if they are cheap compared to other sources, right? People will not think that oh, I am contributing to mitigate global warming so that I can buy the PV electricity. That is not there. They will buy if that is cheap in price. So unit cost electricity calculation. Then what is the government policies, national and state PV policies? We have the MNRE. Have you visited the website MNRE? How many of you visited? Please raise hand.
Sir, can you repeat what you have asked?
How many of you have visited the website of MNRE, Ministry of New and Renewable Energy? Nobody. Last class I given an assignment. Visit MNRE. So if you have not done, please after this class evening today go and visit Ministry of New and Renewable Energy in India, MNRE. Okay. I think other countries, Elena will have in your Nepal some renewable energy organization. Okay, visit that. In India, Ministry of New and Renewable Energy is there. So what is the policy of government of India? You will get there. So that policies you will study in the module 7. Renewable Energy Portfolio Standard RPS, Renewable Energy Certificate RES, preparing a detailed projected report DPR. All these things are subject matter of last unit. Module 8 will be general, contemporary issues, recent developments in the area of solar photovoltaic. So this is the items to be covered. So with your contribution, we will try to cover it in the best way. Okay, your reading, your support is needed. The course objective we have already studied, understanding the basic concept of solar PV, understanding the performance of operating characteristics to design the solar PV. So this is the objective, course objective. This is the aim of the course. But if you study this course, you are supposed to get some outputs. What is the output? Expected course output is you should be in a position to explain physics of solar PV and conversion from light, design PV system for economic need and as well as energy need, analyze the performance of PV system, prepare commercial report on PV system, plan and execute PV panel projects. So nowadays PV is booming. If you study this course thoroughly, you should be able to have a detailed understanding of PV in a big way. Okay. So you can also download so many materials, what is happening in industry, read it, project reports will be there, case studies will be there. In fact, one of my assignment is, what is the assignment? Case study of a real solar PV installation. That will be the first assignment. Okay, I will give it in the next class. Will be take it in your mind. Studying a solar installation is the assignment, so that you will get more understanding practically what is happening. So rules of the class: on time, separate notebook is needed. Your exams will be open notebook. Okay, so you maintain a separate notebook exclusively for this class and write down the everything related to class and the assignments, so that it will be easy for you to refer and write your final exams. Proper dressing. I may ask anytime to switch on your video and respond to my questions. So you should be in a position to switch on video. Okay, not casual dress, proper dressing in the class. So what is happening now is a digital transformation in energy. Have you studied about a digital transformation in any other sector? Some 10 to 15 years back, mobile phones were in the starting, right, in India. 2005, 7, etc. It boomed. Up to 2005, etc. It was a rare piece, right? So in telecom sector, we have witnessed a huge digital transformation last 20 years, right? Like that way, in every sector of the industry, digital transformation is happening. So nowadays, centralized power is there. Now it is going to be decentralized. What is the meaning? Now you are getting electricity from a main power plant in your state. Okay. In Kerala, here means Idukki, the hydropower plants are there. Some coal power plants may also be there. So from there, it is centralized production and distribution to customers. Now the trend is decentralized. If VAT want a power, we should produce in the campus itself. Okay, decentralization. If you want a power in a village, you can produce there itself. So that is the trend. Share of renewable energy in energy mix is increasing. Smart devices and application of IoT will facilitate. So nowadays the trend is IoT, Internet of Things. All things are going to be connected. So with the wide application of IoT, this decentralization and its management will be more easy. We have the concept of smart grid, right? You go and check what is a smart grid. It can be implemented. Now it is not implemented. We can implement it and we can make a system more efficient. So all these things will be facilitated where digital transformation is, if it is occurred. So it will take time, maybe after next 20-25 years. If you look backward, our digital transformation will be happening. So this is the energy units we have discussed last class. Power, some examples. One TV means 100 watt. One CFL means 30 watt. Fridge means 300 watt. One electric motor means 1 kilowatt. This is I am giving to get you a idea what is this watt. So 300 megawatt means how much big it will be compared to these devices. So this is the assessment configuration. We have out of 100, one digital assignment, two digital assignment, three digital. Okay, one is mandatory, two other I have given. Then cat 1, cat 2. So all these things will be 100. So three digital assignments are there, so that you can do your homework and do it better. Okay. So I have given 15th August the deadline. So I will be giving, now it is 10. Next class I will give you the question. Okay. You can do it and submit before 15th. Is it clear?
Yes, sir.
So can you please repeat again about submitting before 15th?
Question I will give. Okay, next class or I will put it in the Teams. What is the question? 15th is the first assignment deadline.
Sir, could you upload the question on BTOP maybe on the...
I will upload.
Thank you,
You
sir.
can take 3-4 days and submit your assignment. It will be simple, but you need to have some reading. Okay. So keep it in mind.
Okay, sir.
So today I will wind up. This is the general introduction. So from the class day after tomorrow, we will go to module 1 and we will start. Okay. So I request everybody to visit some website and get some solarpv.com like that. They will have a blog about solar PV. Okay. MNRE website, what is happening in India in solar. So you take some time, find some time to read the internet resources and get some idea about solar PV. So today I am going to stop here. You can, any doubt means you can ask.
No, sir, no doubt.
Okay, then you can leave, no problem. I have taken attendance. Thank you everybody for your listening.
Sir,
Thank you, sir.
Yeah,
Sir, is it possible to increase the time for the assessment?
that I have freezed. Okay. This 15th, because by the next last of this month, etc., will be busy with your cat one, all these things. So before that, I want you to read and submit. It will be easy, not a tedious job. Okay, I will give question. It will be easy. Don't worry.
Sir, can you
Okay,
please
sir.
upload the question as soon as possible?
Yeah, I will upload by today evening or tomorrow morning.
Yes,
Thank
sir.
you.
Thank you.
Thank you. Okay, you can leave now.
Thank you, sir.
Okay, thank you, sir.
अरे मेरे को टीम में ऐड कर दीजिएगा यार।
भाई
हाँ,
टीम
करता
में
हूँ,
ऐड
अभी कर रहा हूँ। अभी
कर
अभी
दिया।
करता हूँ।
चलेगा
करता हूँ, अभी करता
सानिध्य तू कर सकता है ना इसको?
हूँ।
कर दे। हाँ बता।